Ja, välkomna tillbaka då till en ny stream. Vi har försökt här några dagar med att följa den här raketuppskjutningen. Men det har inte gått så bra. Första veckan så första dagen där så hade de ett problem med markutrustningen då. Det var en ventil i quick disconnecten till boostern, vad jag förstod det som läckte. Så att de bytte ut den till igår och sen så efter det då så de skulle prova igår igen då, men då var det vädret som ställde till det igen istället då. Så att nytt försök idag. Börjar bli lite sliten. Det är ju lite sent där och har ju ett vanligt jobb också 8-5, så att man blir ju lite sliten, så sätt så är det ju. Men samma procedur som igår. Vi har väl ungefär 26 minuter kvar som vi kan se på skärmen där. Det här är NASA Spaceflights stream som de har uppe, livestreamen som alltid är igång på deras. Den kan ni gärna kika in i och med att jag bara följer uppskjutningarna då. Jag har ju ingen egen utrustning där borta, så jag följer dem här, kommenterar dem på svenska så gott det går. Mest för att det är kul. Intressant, tycker det är häftigt det de gör. Men ja, vi kan ta och nu vet jag inte vad som hände där. Men vi kan ta och gå igenom här igen då. Börjar här på marken såklart. De håller på och tankar nu, skulle jag tro. Klar med tankningen här på, brukar de vara runt 3 minuter innan ungefär. Så tar det en stund att fylla upp den där raketen. De åker upp. Åker ännu mer upp. Och sen så kommer de att köra en separation, hot staging, alltså att motorerna på Starship startar innan man faktiskt har separerat på farkosterna då, eller skeppen. Boostern kommer göra en backflip, kontrollera backflip. Det är ganska nytt nu, där de har gjort i ordning, använder sig av en sån här kallad hot staging ring på boostern. Som gör att avgaserna eller flammorna eller tryckvågen eller man ska säga kommer ut genom öppningar då. Finns ju ett litet hål, eller man ska säga, det finns en liten distans mellan skeppet och boostern just nu då. I framtida versioner så kommer den här inbyggd i boostern, så den kommer inte kastas bort, vilket den gör just då. Men den i alla fall har de nyligen då täppt till på ett ställe, så att att den täpper till där gör då att den får kraft, och alltså att den får när Starships raketer startar så trycker den liksom lite mer på den här igentäppta delen och det blir en backflip på den, så att säga. Och det har man gjort för att spara in bränsle. Istället för att använda motorerna för att göra den här backflippen så görs det med Starships motorer, så att man sparar in bränsle på det. Sen kommer boostern tillbaka. Kommer inte fångas av tornet i det här idag. Och det är som sagt igen då också för att de utför så att säga tester på booster nu då. De har haft 3 lyckade alltså de har fångat den 3 gånger, lyckats med, och det har sett väldigt bra ut, så att de kommer att skippa det den här gången för att kunna testa lite andra saker. Förra gången så exploderade den ju innan den hann landa, och det var för att de körde alltså de vill ju att det ska dra så lite bränsle som möjligt, för då ju mindre bränsle det drar och skicka upp den här raketen, desto mer alltså de kan ha mer payload, alltså last i skeppet då istället. Det vill de ju ha, och då för att göra det så kan man komma in i atmosfären i den här vinkeln som ni ser här. Den kan vara lite mer aggressivare, så att själva raketen får alltså draglyft, alltså lyftkraft kan man säga då, så att den saktar ner sig själv. Och då vill man kunna köra den så aggressivt som möjligt. Förra gången så testade de det lite för aggressivt för den här modellen av booster. Så att den klarar inte av det helt enkelt och det var det insidan som kollapsade på den då. Ja, men vi ska se. De ska dra ner på den vinkeln idag för att se hur mycket de klarar. Och förhoppningsvis kommer de landa då. Och landningen kommer ske, vanligtvis så sker de ju med 3 motorer. Alltså de tänder först den inre ringen. 13 motorer, tror det är 13 motorer, jag är inte helt säker på den. 13 motorer tänder de och sen så när de kommer ner mot land eller mot vatten i det här fallet då, så släcker de dem utom de 3 i mitten som då faktiskt klarar att göra så att den här kommer ner sakta och hovrar över marken för en kontrollerad fångst eller vad man säger, för att grepp för att tornet ska kunna få tag på boostern då. Och den här gången så kommer de göra så att de kommer simulera att en av de här 3 motorerna går sönder. Alltså det är bara 2 som tänds. Och då har de den yttre ringen där som de släcker egentligen. För det blir för mycket lyftkraft helt enkelt att ha den på. Men då har de 10 motorer eller 13 extra där då. Jag är rätt osäker på om det är 13 eller 10. Jag tror det är 13 med dem i mitten. Så det är 10 runt om och sen så 3 stycken i mitten. Det blir 13. Så då tar de en av de 10. Det är i kring som den här motorn som har gått sönder finns. Och tänder den istället. Och då ska de se ifall så att de vill testa så att det här funkar. Så att de ska få mer pålitlighet på den här boostern då. Så att kommer den ner och någon motor går sönder ska det kunna tillräckligt sätt på att alla 3 går sönder. Det vill man ju såklart inte, men det kommer säkert testas. Det skulle jag inte förvåna mig om de testar det någon gång. Att de slår av alla 3 och försöker att lösa det här med den här yttre ringen då bara och se om det går. För då har de ju väldigt bra pålitlighet där för då spelar det ingen roll för de går sönder. Eller ja, det är klart det gör, men de klarar sig ändå. Det går bra. Så den kommer landa där. Troligtvis explodera. Inte så konstigt. Varmt och kallt och allt där. Efter det, skeppet kommer att fortsätta sin resa i rymden här. De kommer längs vägen här köra. De kommer testa och skjuta ut satelliter, nya Starlink-satelliter. En ny version av den som är större som bara får plats i Starship. De kommer även testa och köra igång en motor där för att de vill ha kontrollerad så att de kan de kommer upp i omloppsbanan men de vill komma ur den också i alla fall. Och sen så kommer de göra ett re-entry, återinträde. Det är då det brukar bli några spektakulära färger om det. Förhoppningsvis kontrollerat den här gången. Det har inte gått så bra senaste gångerna på grund av lite läckage och sånt där som har skett. Och sen kommer de landa i Indiska havet, strax utanför Australien i alla fall. Australien, Nya Zeeland, det är kring. Och förhoppningsvis så ser vi det på en kamera. Jag ska tillägga där att de har lite test. De har lite par sådana här, det är en värmesköld på Starship. De håller på att experimentera lite grann så att vi får se hur det går. Det viktigaste är att de får in data på hur de här experimentella tiles som de kallar sig, alltså typ klinkersaktigt liknande, det är keramik typ gjord av så att det viktigaste är att de får data på de nya där som de testar och vad som händer ifall man inte har en tile och så vidare. Så att så ser det ut. Vi har även lite tider här. Vi har ju, ska vi se vart den var här uppe. 18 minuter kvar. Så vi har lite tider här som vi kan hålla oss till. 18 minuter kvar. Nej, det här var fel. Flight Tesla. Det här vi är här på countdown. 18. Då har de påbörjat engine chill nu. Och där har vi då alltså att här är det skeppet klart 3 minuter. Boosten är klar efter där. När det är 2 minuter kvar. Ja, så Visst lovar på SpaceX-streamen här, så följer vi den. Jag kommer kommentera lite emellanåt här. Så att vi kör på den. Jag kommer att meddela om tider och så här allt eftersom nedräkningen går. Jag kommer alltså, ja, jag kommenterar lite grann, men vi får se lite hur det vad det som sägs och sådär. Så att jag flickar in lite då och då. Annars så lyssnar jag och så får ni också göra det också. Oj. Gött att den gömde sig där. Så där. Och så kör vi på.
Have a moment though. Let's check in over with Tyler Lionquist over in Hawthorne for the latest on Starlink. How's it going, Tyler?
Thanks, Dan and Amanda. I'm Tyler Lionquist, and I'm a Starlink business analyst here at SpaceX. Starlink is SpaceX's low Earth orbit, high-speed internet that's bringing connectivity both on Earth and in space. Now, for today's mission, Starship is outfitted with 4 Starlink terminals, allowing us to get live views of ship while in orbit and all the way down splashdown in the ocean. Our Starlink satellites are built in Redmond, Washington, which is also where we monitor the health of the entire constellation. So, let's take a quick look for more on Redmond.
Samma video dock.
What a lot of people might not realize when they think about the scale that we're operating is that actually 2/3 of the operational satellites in orbit are Starlink satellites. And then all of those Starlink satellites came from right here in Redmond. We've currently got a constellation of over 8,000 satellites that are flying around in orbit. So they're working together to fill out the whole surface of the Earth, make sure everywhere can have service. So we have these laser links that are connected between the satellites, so each satellite can pass data from one to the other. That is what allows us to have these hundreds of gigabit links between satellites, and that's what allows us to connect every corner of the Earth to high quality, high speed, low latency internet. When you think about that Starlink that you have at home, the technology that's in there and that's in your antenna is very similar to the antenna that's on the satellite. We use what are called phased array antennas, which is a fancy way of describing an antenna that's made up of many little antennas that work together in order to direct their energy to a specific spot on the ground without a motor.
Generally, satellite manufacturing is a very slow process. It takes people weeks or months to build a satellite. At SpaceX, we iterate very fast, and we have learned how to build satellites at the 70 sats a week rate. As we have focused a lot on production rate, we have not forgotten about our satellite reliability, which is critical to our mission.
If you look at the whole world and you ask, where is the satellite industry? It's right here in the USA, in Redmond, where the vast majority of satellites are being built right here. Starlink is a truly game-changing technology, and it's all supported by the global satellite constellation from this space here in Redmond. And we're really just getting started at the very beginning of what we want to do with Starlink.
Now, as we mentioned earlier in the show, one of today's objectives is for Skepp to deploy Starlink simulator satellites that represent the advanced V3 satellites Starship will be launching in the future. And as you can see here, once Starship reaches a nominal orbit, the payload door will slowly begin to open to prepare for deployment. The Starlink satellites will be dispatched relatively quickly, one at a time, like a Pez dispenser, as you can see on your screen. They'll be situated in one long stack, taking up as little space as possible, allowing for an efficient deployment sequence. Once a set of Starlinks are deployed, the next set advances and deploys until they are all drifting away from Starship to prepare for their on-orbit life. Each Starlink V3 launch on Starship is planned to add 60 terabits per second of capacity to the Starlink network.
Förra gången så berodde det på att det var läckage så att själva ombordcomputern, alltså datorn ombord beslutade sig för att det går inte att göra. Så att jag hoppas att de kan göra det idag. Det ska vara jätteintressant att se. Jag hoppas de lyckas.
Thank you so much, Tyler. Okay, let's turn our attention to today's flight profile, which will feel familiar because it is. We're looking to get our first re-entry with this iteration of Ship, and we're again intentionally stressing Super Heavy during its return. The next generation booster is on the horizon, so the objective is to push and learn all we can from this current version.
All right, let's jump right in. As always, it's going to start with liftoff. Super Heavy ignites 33 engines lifting off from Starbase and ascending. It's going to power that ascent for about 2.5 minutes until we get to hot stage separation. Super Heavy shuts down all but 3 engines, deeply throttles the remaining ones, stage 2 lights its, and flies away. We have stage separation, a directional flip. It's going to descend. We're going to do some landing burn experiments and then do a splashdown in the Gulf.
Meanwhile, Ship continues on with its ascent burn, again reaching a planned suborbital trajectory. We'll attempt to deploy 8 Starlink simulator satellites and then head back for re-entry, where we'll be testing multiple experiments, including missing tiles, metallic tiles, and intentionally loading the vehicle's flaps. Ship will also attempt a flip maneuver, and if all goes as planned today, we'll conclude the test with a soft water splashdown in the Indian Ocean. So that's what we have on deck for Flight 10, which is just about 11 minutes, 40 seconds from launching.
That's right, and so just a quick status check-in. So as you said, we're about 11.5 minutes away. We have some good news. We got our latest range and weather status, and surprise, everything is looking green today. So that's the biggest news that we were looking for. Again, weather is the main watch item for today, but we are green right now. We're not tracking any issues with the vehicle or ground systems, so we are looking pretty good for launch. We did all of our normal pre-flight checkouts with all the different vehicle and pad systems. At this very moment, we're almost done, or we're pretty far into our prop load on Ship, and a little bit more to go on the booster.
Yep, looking closely, it looks like we're nearly closed out on Ship, like Dan said, about 70% of the way through on both methane and LOX on the booster side. We'll continue loading prop for a while. We'll close out at about T-minus 30 minutes, 20 seconds on Ship, and then 30 seconds later, we'll finish up loading prop on the booster.
Yeah, so bottom line, a little over 10 minutes to go. Range is green, weather is green, vehicles looking healthy. We're looking good to launch right at the top of our window at 6:30 p.m. Central Time.
Can't wait. All right, now let's quickly talk about Mars, since everything we do is part of our foundational mission to get to the Red Planet. Each Starship launch is to learn more and more about what's needed to make life multiplanetary and to improve Ship to the point where it's taking millions of people to Mars.
Yeah, we've shared the plan previously in the last couple of months. We're looking to start sending the very first Starships to Mars next year. These missions, not with people. We're just looking minimally viable landers, so let's just prove that we can get there. And so we're just going to focus on learning as much as possible, but looking at all of those different phases. You know, prop load, prop transfer on orbit, sending stuff out to Mars, doing the transit, doing the entry, and just doing a landing.
And in our next window, around 2028 to 2029, we're going to attempt to land the initial infrastructure and start delivering more equipment as well, while evaluating available resources on the Red Planet. And we will also have Optimus on board for the ride, who is designed to do the initial heavy lifting.
Oh, looks like we're doing some flap checkouts real quick on the Ship as we are coming up on 9 minutes. Back to Mars, though, as those wrap up by about 2030, 2031. We'll continue to increase the payload per ship, build out more infrastructure out there on Mars's surface, start to mine some of those resources, set up some propellant generation plants, build up some fuel and some oxidizers to send Starships back from Mars. By the time we get all the way to 2033, we're looking at double the amount of payload we're sending with each ship as we get closer and closer to building a self-sustaining presence on the Red Planet.
Yeah, definitely lots of exciting missions ahead of us, and these are going to be crucial to setting up what we'll need for humans to eventually inhabit the planet, and we won't be doing this alone. The Italian Space Agency and SpaceX recently signed a first-of-its-kind agreement to carry Italian experiments on the first Starship missions to deliver
kommer inte
customer
plats man
payloads to
tar
Mars.
dem
So these payloads will
idag,
include a
får jag
plant
hoppas,
growth
om de
experiment,
kommer så långt.
a weather
Jag
monitoring station, and also a radiation sensor
försöker
to
hålla
gather
mig
scientific
lite...
data during Starship's approximately
jag
6-month
hoppas ju så gott
interplanetary
som...
coast
Jag hoppas
phase
att det
from
går så
Earth
bra
to
som
Mars
möjligt, men
and
jag
also on the
blir
Martian
inte förvånad
surface.
ifall det
It's a
inte
really
går bra.
exciting
Det har hänt
mission.
för
Make
många
sure
gånger
to
nu att
work
det inte
really
gått bra,
fun
så att det
for
är
us.
inte något som
We're
förvånar mig i det här
gonna
läget. Vi
launch a
ska
whole lot
försöka
more
hålla
though,
utkik
so,
efter
well, we're just under 8 minutes away
bränder och så
from
vidare
launch
i
today.
motorrummet.
Let's head back over to
Det
Tyler
har
and
hänt
Hawthorne,
ett par
talk a
gånger, så
little bit
att
about how we're going to be
brukar vara
increasing
ganska
the
duktig
number
på
of
att se dem.
Starship launches going forward. Tyler?
Så
Thank
vi
you,
får se hur
Dan
det
and
går.
Amanda. So to put it plainly, in order to launch more Starships, we need to build more launch pads. And that's exactly what we're doing at Space Launch Complex 37 at Cape Canaveral Space Force Station in Florida. Now, Pad 37 has a storied history, most recently with the Delta IV rocket and for the missions for the US government. And prior to that, the pad supported critical development for the Apollo lunar program in the 1960s. And we are honored to have the opportunity to continue making spaceflight history at Pad 37 with Starship. But first, we need to optimize the pad. So earlier this year, we started dismantling some of the existing infrastructure to prep the site for Starship operations. This will include up to 76 launches a year, with up to 152 landings at that location for Super Heavy and for Starship. And to support this flight rate, we plan on building 2 launch pads. Each will have 1 tower that can support launch and landing, plus deflector systems, launch mounts, and water deluge systems. This will also include a propellant farm that will produce propellant on site and serve both launch pads. So there is a lot of work in progress, but Pad 37 is only one part of our plan for Starship operations in Florida. A few miles away from Pad 37 at Kennedy Space Center, our 380-foot-tall vertical integration facility called Gigabay is under construction. Once complete next year, Gigabay will be capable of housing multiple Starships simultaneously for rapid assembly and integration. And meanwhile, at Launch Complex 39A, we're building Starship's infrastructure to support up to 44 launches and up to 88 landings a year, independent of operations at Pad 37. So with 2 launch complexes in Florida, we'll have the ability to fly up to 120 Starships annually, not including our flights from Starbase. So action is well underway in Florida. How's it looking in Texas?
Thanks, Tyler. Things are continuing to look good for launch here in Texas, so getting pretty close here with just under 6 minutes left. You mentioned Gigabay. We're currently laying the foundation for a Gigabay here at Starbase as well, and we expect it to be up and running sometime next year. So yeah, there's a whole bunch of Starships on the way, and we're going to need more hands on deck. So come help us build the gateway to Mars. Visit spacex.com/careers to see all of our openings.
Yeah, I've been here for a couple of years now. Nowhere more magical, more inspirational on the planet. If you're a space nerd, you can come be like Amanda and build these things for real. It's pretty insane. It's super exciting. And yeah, come check us out. All right.
Absolutely. It's surreal to be here for sure. Okay, so we are looking like we're about 5 minutes away from launch and heading into terminal count. Range and weather are continuing to look good, and prop load continues on both stages of Starship. We'll close out here in just a minute or so.
Yeah, we're just about done. It looks like, let me grab my numbers real quick. We're not tracking any issues. We are just creeping up to 90% full on the locks on the booster, a little over 93% on ship, or sorry, fuel on the booster, and then ship we're just about to close out, so only a couple of minutes to go there. Once we're done, you've got just shy of 11 million pounds of liquid propellant on board those 2 different stages. We'll see a couple of final things happen. Well, you can't really see it. It's all going to be happening in our ground systems as we'll do pushbacks, clear all of the propellant out of those lines that are flowing up through the tower and into the vehicles, and get ready for launch. We just did our final guidance, navigation, and control system checkouts. Our flight safety system is being armed right now, and we're doing our final wiggle checks shortly with the engines on the thrust vector control tower steering the rocket. If we need to hold, which we are not currently tracking a reason to hold, that would come at T-minus 40 seconds. You saw us do that yesterday. We can hang out there for about 8 minutes or so right now. That's the point. It's built into the countdown. If we need to wait for clouds that just won't go the heck away or any other issues, we can hang out at T-minus 40 for a bit. But at the moment, we're not planning to do that.
Now, once we pass that T-minus 40-second mark, a number of events are going to occur in rapid succession. The ground spin and ignition systems come up to flight pressure, ship will switch over to internal power, and after that, the QD arm lockout is removed in preparation for retraction, which occurs shortly after T0. And once we pass that T-minus 40 seconds, we do still have the ability to then recycle the count under certain conditions back to T-minus 40 seconds and hold there to assess what happened, and if we can proceed again back down to liftoff.
That's right. We do have at least one point of no return, though, if the water-cooled flame deflector underneath the launch mount fires off. That happens a little bit after T-minus 10 seconds. That doesn't turn off once it starts going, so we would have to stand down for the day if we do hit a hold or an abort at that point, so we can refill water tanks. At this point, we're not sure if we'd be able to attempt tomorrow because we have fully loaded the vehicle. We have to do a lot of fancy scheduling to get propellant in here as fast as possible, but again, we've got a pretty heroic and amazing team that works all of those logistics, got us into our attempt today after we did a unplanned wet dress yesterday during our attempt. So really exciting to see. But we're coming up on 2 minutes. We've got a green range. We are green for weather. Green has always been my favorite color, only more so now. And we are not tracking any issues with the vehicle today. So we are looking
Anledningen till att de bara kan stå 8 minuter är för att bränslet blir varmt och börjar avdunsta, så att de kan inte stå längre än så, utan de börjar tanka av, alltså tömma. Trycket ökar och allting, ja, så att det är därför de inte kan hålla längre än så.
Super useful to be able to have that, but again, not currently tracking any issues, so hopefully we'll be good to launch today.
All right, coming up on 90 seconds, we've got a pretty good crowd gathering with us right outside Star Factory here at Starbase. Looks like we're getting a quick TVC, that wiggle check.
This is my favorite view of the rocket.
Right under the launch mount.
Engine chill.
All right, so we've got crowds gathered out at Hawthorne, crowds gathered here at Starbase.
Super fun to see people getting to watch out on the front lawn now.
1 minute to go to launch. All right, so again, our hold point comes up at T-minus 40, not tracking any reason to stop there, so we should see us go right through that. All right, we are through T-minus 40. We are counting down. We're going to let our flight director, Maciek Batura, take us the rest of the way. 30 seconds, the 10th liftoff of Starship.
Systemen och kört ändå. Så att det behöver inte vara hela världen ifall det stannar nu.
T-minus 15. T-minus 10. 9. 8. 7. 6. 5. 4.
Lyfta idag.
3. 2.
1. Se. Lyfta.
We have liftoff.
Yes. Bra jobbat.
Vehicles pitching downrange. Booster chamber pressure nominal.
All right, we're a little over 40 seconds into flight. 33 out of 33 rapid
avionics power and telemetry nominal.
Getting good call outs, healthy systems on the booster as it starts to pitch over the Gulf.
Se, vi kommer in på max Q på 1 minut. Där borde det vara.
All right, we're a little over 1 minute into flight, about to pass through max Q.
Max Q.
Där passerar vi det.
All right, so we are through the period of maximum dynamic pressure, max stress on the vehicle as it continues to fly.
Our next major event is going to be hot staging, which is happening in just over 90 seconds from now. To get ready, the booster will shut down all but 3 of its Raptor engines. The clamps holding the 2 stages together will release, and the Starship second stage ignites its engines. The ship then separates from the Super Heavy booster and heads to space. At the same time, the 3 engines still firing on Super Heavy will flip the booster around. 10 more engines will ignite for the boost back burn, putting the first stage on the path for splashdown in the Gulf. As we mentioned earlier, the hot stage will be jettisoned for this flight, and that should occur just after the boost back burn. So we're about to shut down the first stage and perform hot staging. So let's just watch and listen.
En motor har dött, ser jag. Det är lite dåligt, men det behöver inte betyda någonting speciellt. Vi ser 02:36 ska de stänga av motorerna. Se vad som händer här. 36 borde de stängas av alla.
All right, seeing the engine start to throttle down.
Här någonstans, där ser vi dem, ja.
Miko.
3 stycken kvar. Kommer hot stagingen här, 48.
Ship ignition.
Ship ignition hör vi. Där har den.
Boost back burn start up.
Kontrollera
Stage
lite.
separation.
Ska vi se ifall motorn... Ja, den motorn är fortfarande död där. Tyvärr.
Stage separation confirmed. We've got 6 engines running on ship. Booster is doing its boost back burn, continuing now towards its splashdown site in the Gulf. We are seeing all 6 Raptors lit up on ship.
Får vi se om vi får en bild på boostern snart.
You heard them report ship chamber pressures nominal, so that chamber pressure, just that expected thrust level in those Raptor engines on the ship. 3 vacuum optimized, 3 sea level, all looking good.
Borde vi hot staging? Nej, jättesam menar jag. Av hot staging-ringen. Vi ser, det har ju brand där igen, ser det ut som.
There's a view into the business end from the ship.
Boost back burn shutdown.
Det ser inte bra ut. Brinner alltid där bak. Får se om det.
All right, so at this point we finished our boost back burn, so that was shut down. So that's the first of the 2 burns after a launch that the booster is going to do today. So now it's headed towards the Gulf. It's not going to be quite as an aggressive of a flight down. We relaxed that angle of attack a little bit, but we are then going to be looking for it to do its engine tests for the landing burn, and those are going to be a little unique this time.
Yeah, typically we start with all 13 inner engines lit for that landing burn and bring that down to just the center 3. But one of our test objectives for today is to simulate what an engine out situation would look like. So we're going to be intentionally turning off one of those center 3 and instead lighting one of the engines from the middle 10 ring.
Yeah, we did see one of those engines in the middle ring shut down during the initial ascent.
Right.
Oh, looks like we have hot stage jettison. You can see it floating away there to the left of the booster. Yeah, we did see one of those middle engines shut down during the ascent. Again, we are resilient to engine out on Super Heavy. That's why we're able to get through our ascent. Starship flying on the expected path. There's still a chance that engine could be back in the mix for the very start of the landing burn, so we'll see if we light up all 13. But we've even done a landing burn at the tower with an engine out, so very resilient. We'll see how it does on its way down to the Gulf, though.
Vet inte om det är kontrollerat eller inte.
All right, so we got a couple of minutes. That landing burn start should be just about 40 seconds away.
När boostern har landat brukar vara ungefär där.
That's always rad. You can see the
boostern.
Could see the boost plume itself in the background as it was coming in.
Där ja. Får se om vi ser hela vägen nu här.
All right, about 20 seconds to landing burn.
Ship Raptor chamber pressure is nominal.
Vagel.
All right, here we go.
Landing burn startup.
Nej, den motorn är nere, borta.
Looks like we got 12 of those 13.
Down to 3, including one of the middle ring.
Så bra ut. Det är bättre här. Intressant att skidpinsen har stannat.
Down to 2. Nice little hover. And landing burn shutdown. And into the Gulf, here we come. And the booster has splashed down.
Incredible flight for booster today.
Meanwhile, back in space, about 7 minutes into today's flight, ship continuing its ascent burn. This goes until just about 9 minutes into our flight. That ship engine cutoff is slated for 8 minutes and 57 seconds. We are going to see those 3 RVAC, the Raptor vacuum engines. Those are the bigger circles in that little indicator on the bottom right of your screen. Those will shut down first, and we continue burning for a couple seconds longer on those inner 3 before we hit SECO, or second engine cutoff.
Yeah, these views are looking great. Once again, thanks to Starlink for getting us these views. It's just incredible. And we just heard the sound from booster.
So we just got a late boom from the booster.
Yeah, we have ship engine cutoff coming up here just shortly. And as we mentioned, today's flight test is not an orbital flight, but rather one that demonstrates Starship's orbital capability.
Starship is on terminal guidance.
All right, entering the final phase of this burn. Under 30 seconds to go.
Där 20 sekunder ish. Där ser vi, det är någonting som är uppe i där. Något som blått. Det ser ut som att det brinner.
All right, shut down the vacuum engines.
Men det gick bra.
Ship engine cutoff.
We shut down those center 3. Successful ship engine cutoff.
SECO, baby. There we go. That's what we want.
Nominal orbit insertion.
All right, we just heard the call out for nominal orbital insertion.
Jag är lite försiktig med att säga det i och med att det kan börja snurra nu.
All right, so ship is in space. There we go. We're seeing the flaps starting to move into a stowed position. That's why it looks like your camera's moving.
Yeah, exciting to see Starship safely in space and super pumped to see all the team's hard work in action here today. And of course, as guaranteed, it's been an exciting day so far. We successfully lifted off right on time at 6:30 p.m. Central Time. Thankfully, our weather was looking good today. Yeah, and booster, we had our soft splashdown in the Gulf, so ship continues on.
Yeah, ship able to complete its ascent burn all the way in. You can see some of the shadows start to creep as it's going to be eventually flying into an orbital nighttime. So we'll see some daylight start to go away. But ship is in orbit, completed its burn. And, I mean, that's just the beginning. Now we've got a whole bunch more to go. So we've got some exciting demonstrations planned while we're on orbit. That right there, we just saved the FTS, the flight termination system. That's that automatic flight safety system we have on the vehicle. So that is now turned off while ship starts its coast period. We are coming up, our next milestone is going to be the deployment of those Starlink simulators. We've got some payload inside of Starship that we're hoping to deploy into space for the very first time. That deploy is supposed to start at about 18 minutes and 27 seconds into the flight, so just about 7 minutes from now. That deploy will take place over a couple of minutes. It'll go about 1 satellite a minute, so we'll be spread out over that. It might get a little dark, but we've we've got a couple of views that we can show you
Känns det väldigt
to see
pålitligt.
that deploy in action. After that, we're also looking to do a relight of a single Raptor engine while we are in space. We've done this once before. This is not necessary to deorbit, as we are in a suborbital trajectory, but this is essentially a chance to test out what we need to be able to do a deorbit burn. So we'll be doing that a little bit later in the flight, about 37 minutes or so into the flight, and then we get into re-entry. We're looking to get that light show and, more importantly, get that really critical data about the ship's heat shield.
Yeah, exactly. At about T plus 45 minutes, we'll be heading for re-entry. Again, running those experiments with the tiles. We're going to be doing missing tiles, metallic tiles, and also intentionally loading those vehicles' flaps. Hopefully we'll also see a splashdown in the Indian Ocean today.
Yeah, we were able to get to a re-entry last time, but we didn't have full attitude control, so we weren't able to go in, heat shield first the way we're designed to. So we ended up losing contact with the ship before we could make it all the way through. So you still get data, but you're not really getting the data that we want to make sure we're kind of stress testing the vehicle. As Amanda just said, we removed a bunch of tiles, and we do this in some intentionally scary places on the vehicle because we're really looking, are there spots that were vulnerable to this before we ever start moving towards, putting ship into a full orbital mission to then do re-entries a little bit later on. So really, really critical to get that data, really looking forward to a controlled re-entry.
Yeah, for sure. As we always say, our main payload is data, but today we also have some actual payload on board, and those simulators that Starship will be deploying, we'll see coming up here in just a few minutes. These are dummy satellites that are about the same size as our V3 Starlinks. We have 8 in the Starship Pez dispenser and expect to deploy at a rate of about 1 per minute, as Dan mentioned earlier. Starlink is critical in all of our flights on Starship to get our main payload data, as we always say. And in fact, it's Starlink that's currently providing these views you see as Starship cruises a couple hundred kilometers above our home planet and provides real-time telemetry through every phase of flight.
Yeah, we took a peek inside of the Starship payload bay there for a second. So there's 8 of them there. They kind of look just big steel plates, essentially. They're roughly the same size as those V3 satellites. When we do get that view inside of the payload bay, the payload door will kind of be on your right, and we'll start to see them go out like a Pez dispenser. Yeah, here's a look inside. So those right down there in the center, they're kind of 2 stacks of 4 on either side. And then the payload door is just to their right. And so we'll look to see that open, and then those satellites start to go. We vent the nose cone, so we essentially bring it down to vacuum before we open the door. That was one of the things we ran into on the last flight, as when we had that fuel diffuser fail, the pressure in the nose cone became basically too high for the actuator of the door to open. So that's why we weren't able to get the door open that time. We have not seen anything like that on this flight. Everything's looking good with our fuel tank and our fuel press system. So we are hopefully just a couple of minutes away from seeing that payload door open and getting to our first ever payload. It's not the first payload we've ever carried, but it's the first one we're going to try and shoot off into space.
Jag vet inte hur det ska se ut det här, men typ rök och sånt där.
All right, so I think we're supposed to open the payload door in just about a minute and change. And you're seeing a little bit of residual gas. And we opened the door once. I want to say it was back on flight 3 when we were able to make it up into space. And you'll kind of see a lot of that gas rushing out into the vacuum of space. It's the residual that's left over after we've already vented it down. So kind of a cool light show. And then we'll get ready to deploy those payloads out.
Hoppas det, så inte är något annat som händer. Man vet aldrig. Det som är så spännande. Så det är 2 minuter kvar.
And as we mentioned, so we have crossed over now at this point into an orbital nighttime. So views from the outside will get pretty dark but we'll see what we can see. We do this by design. We've been launching these later in the day here in Texas to try and get daytime views when we splash down. So it's daytime over in the Indian Ocean, where we are currently headed.
Just a few seconds until we expect those payload doors to open.
Den borde vi se på högersidan där.
All right, one more time. Open the pod bay doors, Hal.
Känns något man har förtroende för detta. Där ser vi något. Tjoff. Oj, åker ut. Går det bra? Den åker upp i alla fall. Snyggt. Kommer allt att funka? Vet ej. Men det är öppet i alla fall.
So we are currently in payload deploy prep.
Okay. Good so far. 17:33. En
And
minut
the
kvar
door
till
is
det ska
open.
börja och skicka ut dem. Och se om det påbörjas enligt tiden eller om det börjar före.
All right, so the payload door is open. We should see the first satellite start to deploy at about T plus 18 minutes and 27 seconds. So should be only about 30 seconds. So one step closer. Hal listened this time. He cooperated. He opened the payload door for us. There's a view kind of behind the Pez here looking out into the vacuum of space.
För det är
About 15 seconds until
lite
payload
skillnad
deploy.
på att göra det här på jorden också. Men ge oss bild då. Så, ja. 37 och 27 var det. De ska ju börjat nu.
Ship is transitioned to payload deploy.
Se om det händer något. Nu händer det något. Eller, vad händer? Vänta. Nu händer något. Sen då, men ut. Ja!
There we go.
Sen om den åkte ut, det vet jag inte. Men det är bra. Det är bra. Nice. Snyggt jobbat. Applåd för det.
Pew pew. Been waiting way too long to do that. There we go.
There goes another one.
Ja, den hade vi jobbat på där.
Super exciting moment, as you can hear the energy in both Hawthorne and Starbase. Everyone's super excited for finally getting to deploy some of those simulated satellites.
Pez system moving down. Next row. There we go. As we said, we're going to do about one every minute or so. And this is just kind of a dress rehearsal for when we're going to be deploying the V3 satellites. And these are just a massive, massive increase to Starlink's capability. Each one of them has, it's 60 terabits per second of capacity that's going to get added to the network per launch. That's 20 times more than what we're adding with every single Falcon 9 launch today, which, you know, step increase in capability. There goes another one. All right, so as we said, we've got 8 total that we're going to go through today. It's about a minute for each one, but looking good on payload deploy.
Ja, som sagt, om man får jobba på den. Ja, det funkar ju. Ja. Snyggt. Som sagt, de har kanske lite att jobba på där, men den är ju faktiskt... Ja, kul att se. Det får inte lyckas göra det här. Så åker vi upp en sväng.
All right, so we're about halfway through. When we actually start launching the V3 Starlinks on Starship, we're going to be flying about 60 each time. So it'll be about an hour to get through a full stack. But again, it's just going to be a massive increase in the amount of bandwidth. It's going to enable gigabit upload, download for people with Starlink, anywhere on the planet. And for us, Starlink is just a tremendous part of just the Starship flight test program.
Yeah, absolutely. Always getting us that data. And yeah, the amazing views we have on the vehicle today.
Yeah, views brought to you by Starlink of us deploying Starlink simulators before we deploy actual Starlinks. How deep does it go? All right, another one firing out.
Det ser typ ut som att det är det. Så ner. Och så
Pez looking smooth today.
Göra någonting. Släpper taget typ. Och så upp. Låt mig se det här då. Ja, okej. Så tar den tag i nästa. Och så tar den upp den igen. Så att de kommer loss ifrån varann. Ja. Och sen så åker de ut. Men, bort. Jag ser. Och så åker en ut. Det är ut som.
All right, looks like we've got one left.
Almost there.
Och sen så åker han in igen.
Yeah, there you go. One remaining, so 7 of the 8 have been deployed. One more to go. And then we will have completed our first ever payload deploy operation. Just a reminder, we're on a suborbital trajectory. These satellites on that exact same suborbital trajectory, they're going to burn up entirely and are on that same trajectory towards the end. So the last one has been deployed. Starlink simulator payload complete. Heck yeah, everybody.
Loving the energy from Starface and Hawthorne.
There, now it's empty. Looking a little lonely, but
successfully deployed all the simulator satellites.
Really cool to see them all out there. Again, people that have followed know Starlink's really critical for the Starship program, in addition to getting all those views back from the cameras on Starship, which this is an external view. As I said, it's dark outside right now. The lights are off, so it's going to be hard to make stuff out. But in a little while, the sun's going to start coming up as we get to re-entry, which is going to be really critical. We use Starlink for Starship data. Cameras also use it on the cameras that we use to bring you views of these launches, and also hopefully of the re-entry and splashdown. We'll see what we get from the Indian Ocean today. And that's just kind of how it all comes together. Like, we're using Starlink on the planet, off the planet. with Starship, we actually get pretty insane. If you're in the space industry, you know bandwidth to space is usually pretty minimal. We get about 120 megabits per second. That's split between our high-definition video and real-time telemetry. We get that every phase of flight, including re-entry. So it's not just giving us views of re-entry, but we're getting all of that engineering data in real time through phases that it used to be impossible to get that in real time. So just really incredible.
Yeah, Starlink definitely affords us all this capability. And reminder, it's the world's largest satellite constellation operating in low Earth orbit to deliver high-speed, low-latency broadband internet. This provides internet access to people all around the world, many of whom had never had connectivity before. Today, Starlink serves more than 150 countries, territories, and other markets, with over 6 million active customers and counting. To meet the growing global demand for high-speed internet, SpaceX expanded its factory in Bastrop, Texas, and also introduced Starlink Mini, as well as an upgraded version of the Starlink standard kit.
All right, now with payload deploy complete, pew, 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 Starship is now going to close its payload bay door and continue to coast towards Earth, around Earth, towards the Indian Ocean. Sorry, I'm really excited today. We are in space, people. Still a lot of major events to come, though. We are looking to relight one of those Raptor engines at about 37 minutes, 33 seconds into the flight, followed by atmospheric entry, hell of a light show, and splashdown. So we're going to go on a quick break, take a quick coast, sit back, enjoy the views. A little bit dark now, but they'll get better soon. A couple of space jams. We'll be back in just a few minutes for that Raptor relight and then re-entry. See you soon.
Ser man det om de har stängt? Det ser ut som att det är stängt. Det är ju inte öppet i alla fall längre. Så att nice. Där ser vi en sån här CPV som de heter. Ja, precis i kameravinkeln här. En sån tub som exploderar. Intressant konstruktion ändå. Kan sätta nästan pengar på att den här finns som 3D-modell snart. Man har ju sett dem ladda dem så att det kommer att se ganska mycket hur de är ihopsatta. Ja, men den ser stängd ut. Snyggt. Härligt att se att de lyckas med det. Får se, det mest spännande är faktiskt återinträdet. Det ska... ja, får se hur det går om man kommer dit. Ja, jag vet inte hur ni gör när ni tittar på de här streamsen. Jag har flera olika vyer uppe så jag kan se vad som händer. Här har vi en annan vy. Oj. Som ursäkta. Går lite repeat eller lite åter replay. Det var en Raptor som hade lite problem där som spottar ut sig lite. Men snart är ju Raptor 3 på gång in. det blir nice. Se vad som händer där, om det lär ju vara lite, alltså när man tar en ny produkt i driftsättning så brukar det ju vara lite små saker som man brukar få fixa till innan det är åtgärdat allting. Jag misstänker väl att det kan vara så i det här fallet också när de byter till Efter 3. Det ska ju vara testa allting, men det är ju, de har ju kämpat rätt bra med Raptor 2. Så att den är ju väldigt pålitlig nu. Tycker jag själv i alla fall. Det här första lyftet de gjorde med Starship i första testet. Då var det ju väldigt illa kan man säga. Det var många motorer som exploderade och som slutade brinna och ja. Sen dess har det bara varit förbättring. Det var en förra flygningen tror jag inte har varit någon. Kanske också en eller två är det som har gått. Men inte inledningsvis liksom. Så det har varit väldigt pålitligt skulle jag säga. Hyfsat bra tracking där de har på NASA Spaceflight också. De brukar alltid ha bra tracking. De brukar ju komma everyday astronauts. Brukar alltid skicka ut 4K-klipp sen. Den kan jag också kolla in framöver om man har fått någonting. Han har också väldigt bra tracking på den. Så kan man se. Väldigt långt upp. Jag vet inte om de brukar ha. Jag tror de brukar se hela vägen upp till hot staging. I alla fall. Så det är häftigt. Rekommenderas verkligen. Så det är de jag följer. NASA Spaceflight och Everyday Astronaut. Sen har jag också Vi. Ursäkta. Vi som jag följer också. Men ja, NASA Spaceflight är de som har, ja, Padre också finns det som här, men jag tycker NASA sköter filmningen bra så att jag gillar att ha dem som referens här, och SpaceX när jag gör mina streams. Se hur det ligger till här. Raptor in Spaceflight demo. 2 minuter kvar där. Det kör vi över till dem här, får vi se. Börjar vi se lite ljus glimpar här också. Kommer över Afrikas kust. Grym musik också. Ja, vi väntar in motortestet som ska göras. Så tar jag en liten paus länge.
right, welcome back, everybody. If you're just joining us, Starship just successfully deployed its first ever payload. We got 8 of those Starlink simulators out, and now we are expecting the relight of a single Raptor engine. That should be coming up in just a little under a minute. We'll be lighting just one of those Raptor sea levels in the middle there. This is not a deorbit burn. It's a demonstration of what we'll have to do for deorbit burns, but we've done this once before. This is something we're really going to have to do when we're doing orbital missions, so it's a pretty critical test. We are just a couple seconds away. Sorry, we're about 20 seconds away, psych. So we got a little bit more time. So we are going to see one of those Raptor engines light back up. We are through the deorbit demo gate, so we should be seeing it momentarily.
Grafiken över motorn. Får vi se om det händer någonting här. Så 20 sekunder.
Relight demo startup.
Där. Ska vi se.
And shutdown.
Okej, låg lite efter.
All right, looks like we confirmed the relight of one of those center Raptor engines. Second time we've done that, super exciting. Huge congrats to the team on this milestone. Very exciting to see.
That was a cool light show. Yeah, I get to do a mini version here. So again, that's going to be really critical for when we're doing deorbit burns. Like as you're going through, which if you don't have one of these, my God, they're so much fun. But like you're able to actually like light, Dan, turn it on. Light that engine. Not set my co-host on fire. And that's what we'll eventually do to, break out of orbit, come back down to Earth. So really cool to see one of those engines light back up again in space. That was our last in-space thing.
Very exciting. We're going to be heading back for re-entry at about T plus 45 minutes. So we're going to take another quick break and we will see you soon.
Så ska vi se 37. Så har vi 47 va? Starship Entry, det är då det börjar hända grejer. Får vi se. Och där har vi en till klick inuti. Nice. Sjukt att det är bara 3 millimeter plåt där. Alltså rostfri plåt, 3 millimeter. Det är ju ingenting där. Alltså. Så jag hoppas inte det börjar snurra för mycket och ha sig. Någonting som hänger där bak på flapsen eller vad? Det var någon testgrej. Jag hoppas vi får några fräsiga vyer då. Återinträdet.
Starship is slowing for entry.
Koll på hastigheten där också och höjden. De brukar köra testerna från 10 kilometer när man kommer ner. Nu ligger vi på 127 kilometer. 26. Så det är lite högre upp. 26 000 kilometer. Men 27 vi ska ner till småningom man kommer inte ihåg. Hur går det ner innan vi är förbi det farliga. Men det är typ 6 perspektiv gissar jag bara helt och hållet. Ja, vi väntar in lite utan bilderna så länge.
Starship is approaching entry interface.
Ser ju i alla fall att de har lyckats ställa Starship åt rätt håll, alltså göra redo för re-entry, så den har värmeskölden rätt håll, så att vi borde förhoppningsvis se ett lyckat test här. Så länge vi klickar. Det ser ut som någonting har gått sönder där bak i alla fall. Men vad? Svårt att säga. Någon spännband som fram där. Kanske är snyggt ut i alla fall. Snyggt och rent. Den håller i sig. Det ser typ ut som att ser den här triangelformade biten där framför gångjärnet höger i bilden. Blänker lite nu. Den är lite fräsig. Liknande Dragon-kapseln.
All right, so we are back. We are about 45 minutes into the 10th flight test of Starship. And as you can see, the light show has started. Re-entry has begun. We are starting to re-enter the Earth's atmosphere. We're moving about 5 times the speed of sound, and we're about to start barreling through the Earth's atmosphere and head for a splashdown in the Indian Ocean. We don't plan to recover the spacecraft today, but if we do make it all the way down to the water, who knows? But the goal of this part of the flight is to learn as much as we can about the ship's heat shield. A fully reusable, rapidly reusable heat shield for a spacecraft has never been done before. It's one of kind of the hardest engineering challenges still out there for us. And so this is the time to really dig in and get that data.
Yeah, absolutely. And re-entry is a critical phase of flight, so we'll need information on how the ship's system end up performing. And Starlink will also help us gather as much data as possible, which is really the main reason why we do these flight tests. Starlink provides us with one more path to collect data to help us rapidly iterate on Starship's design. And if the ship manages to make it all the way to re-entry, we'll collect valuable data on the spacecraft flying through the Earth's atmosphere at hypersonic speeds or more than 5 times the speed of sound.
Yeah, throughout history, a lot of times this is when you go into just a complete data and insight blackout, where that plasma sheath builds up around the outside of the spacecraft that blocks all of your signals that are trying to fight through to talk to either satellites out in space or towers down on the ground. Starship's big size kind of gives us awake, but what really helps us punch through is the fact that we're using Starlink. We're operating at just a much higher frequency. That's not what we want to see. So we just saw some of the aft skirt just take a hit. So we've got some visible damage on the aft skirt. We're continue to re-enter though. And again, we are intentionally stressing the ship as we go through this. So it is not guaranteed to be a smooth ride down to the Indian Ocean. We've removed a bunch of tiles in kind of critical places across the vehicle. So seeing stuff like that is still valuable to us. We are trying to kind of push this vehicle to the limits to learn what its limits are as we design our next version of Starship. So 47 minutes, 45 seconds into the flight, excitement ticking up a little bit on re-entry already, but the light show is continuing. This re-entry is going to take about 20 minutes or so until our plane splash down. We were trying to splash down about 1 hour and 6 minutes into the flight.
Yeah, and one day Starship is designed to land on Mars where there are obviously no runways or other humans to help us out. So we are doing propulsive landing instead of more traditional means such as parachutes. And propulsive landing enables us to have more rapid reusability with these vehicles.
Yeah, the ship itself, it's a little over 50 meters tall. We've got those 6 engines on board, the 3 vacuum, the 3 sea level, and they're down in that aft skirt region, which
flaps have control.
All right, so at this point, the flaps have control. That means we're getting into a dense enough part of the atmosphere that the flaps can start controlling us. We're not only reliant on those kind of reaction control system thrusters.
We're going to continue hearing some call-outs as the ship makes its way back to Earth. So when we hear entry max heating and entry max Q, that will mean the ship has made it through the maximum heating and aerodynamic loads it will experience as it returns. So if it makes it through those, you can say we're doing pretty well.
I will say I'm happy re-entry cleaned off this camera for us. It was a little dirty from the weather, so thank you Plasma for giving us this view as we start coming down. The hit we saw to the skirt, definitely interesting. I will note, when we started doing these missing tile tests, we were intentionally removing them only in the skirt, as that's, you know, that's not over your fuel tanks or anything else that's kind of structurally critical for keeping the entire vehicle together. That obviously exposes your engines, so that could do some things for our landing burn, but for now, we are obviously continuing with this re-entry. We are committed. Indian Ocean, here we come. 50 minutes since launch. We're going to see those colors start to build up a little bit. We are at the point where we're in dense enough atmosphere that the flaps have control. So about 74 kilometers in altitude. And you were starting to see some sunlight, so we intentionally time these launches right now so we have daylight. The sun should actually come up over the horizon on Starship in about 3 minutes. So as we get a little bit further into this re-entry, that inky black below you is going to start to look like clouds and hopefully a bright blue ocean as we make our way down onto the other side of the planet. We've got these cameras. These cameras are really cool. We added these several flights ago, looking directly at the flaps as not just the heat shield, but these flaps, how they're able to control the vehicle, withstand that re-entry, the seal locations, so kind of where they connect to the ship itself are some of the most critical. We will do missing tiles on those where, again, we're trying to... We're kind of being mean to this Starship a little bit. We're really trying to put it through the paces and kind of poke on what some of its weak points are. I mean, we even have missing tiles over some of those fuel tank sections of the ship itself. And so we're really trying to see what are our limits. We're doing this over a completely empty area over the Earth. Look at our Raptors there. We are, assuming we make it all the way down to the ocean in one piece, we will attempt a flip and a landing burn. We do have at least one buoy, everybody's favorite camera person, out in the Indian Ocean right now, being powered by Starlink. So that's at our planned landing location. So if we're able to get any live views of the ship, that'll essentially tell you that we nailed our target. Able to do that on our 6th flight test, do it in the daytime, which was really exciting.
Ofarlig höjd. Oh.
All right, so we're about 10 minutes until we're probably going to start hearing some of the other big milestones coming up.
Yep, in about 10 minutes, like Dan said, Starship will be transonic. This is going to be the period of flight where the velocities of airflow surrounding and flowing past the vehicle are concurrently below, at, and above the speed of sound, so somewhere in the range of Mach 0.8 to 1.2. For reference, commercial jets have a range of cruising speeds, but most of them fly at speeds between Mach 0.74 and Mach 0.85, so that's 480 to 575 miles per hour or 770 to 930 kilometers per hour.
And after transonic comes subsonic. That just means you're slower than the speed of sound. We're still well in excess of that right now. But by the time we hit subsonic, we're essentially belly flopping down. There we go. There's that sunlight. So we're seeing the Earth now come back into view. One of the other things we're doing during this, and you're going to see Starship kind of pitch in some pretty, not extreme ways, but a little extreme, as we're trying to really stress the structure of it, of the ship itself, specifically those aft flaps. So the ones in the very bottom of the vehicle. We're pushing not just how well does the heat shield hold up, but how well does the ship structure hold up. We are pushing it beyond essentially what we think we'll have to fly at to do something like a return to launch site. So again, may not be a very smooth ride downhill, but we're doing that by design. We're really trying to find what are the edges that we can operate at, build up a good data set. But sun is up, clouds and water down below us. We are just about 10 minutes away, a little less than 10 minutes now, until we start hitting transonic and then subsonic. Once we hit subsonic, we're basically just belly flopping.
Det ser ju bra ut i alla fall. Bortsett från de skadorna där bak som jag vet inte vart de kommer ifrån. Men det ska inte påverka jättemycket, ska jag säga. Frågan är om de kan tappa hela flapsen. Jag tror de skulle.
All right, so about 55.5 minutes in, you can see the sun is up. Again, we intentionally designed these flights to lift off in the evening here so we get these daylight views so we can get as good a video as possible on the ship, assuming we make it all the way down. We've got at least one buoy powered by Starlink that's out there in the landing zone in the Indian Ocean, hopefully giving us a view again. If you see any live views, not from the ship itself, that means we nailed our landing target.
Starship is past peak heating.
All right, we just heard the call out that we're past peak heating, so things are looking good so far.
Yeah, looking good.
Ja, det ser för bra ut, men good kanske.
And at this point, again, the flaps are controlling, so this movement you're seeing is that forward flap moving to try and just maintain control, maintain attitude of the vehicle as we're coming down.
Ser att det blir lite varmt. Men det är ju inget konstigt. Det ser bra ut. Så satt bortsett ifrån bakre flapsen där då. Men främre flapsen ser ju oerhört bra ut faktiskt.
Checking in on one of our flaps. We got one of these cameras on all 4 of the flaps, 2 in the front, 2 in the back, giving us really good close-up views. As we obviously don't have a camera that can see the entire heat shield. These give us kind of the best that we can do. But looking at those flaps is really, those are just, you know, super critical for controlling the ship. You have some ability to maneuver kind of cross range. So as you're coming in, you can see in that indicator at the very bottom right that we've pitched up quite a bit. So again, we are maximally stressing those aft flaps right now. Looks like we got a little bit of burn through the very bottom part of it. Everything's still looking good. Ship maintaining control.
Catching points, alltså fångpunkterna som den ska landa på. Tanken är det här, va?
We should be just about 5 minutes away until we hear that we're transonic.
Så vi är nere i 16 000 km i timmen. Ungefär 40 kilometer kvar i höjd tills vi är på känt territorium, så att säga. Sen har de ju sagt, de har ju den bakre gången är ju helt borta där, i alla fall. Det har ju brunnit upp för länge sedan. Men du har det i mitten och så har du ett fram. Så länge som det är grönt så skulle jag säga att det här kommer gå bra.
Still a little bit toasty on the aft skirt of the vehicle as we continue coming in.
Again, we are intentionally stressing the flaps so we can learn all we can.
Frågan är ifall det där är något typ som de har
so now
sensatt eftersom
we're already well past peak heating.
När vi kommer ner i en viss höjd så börjar de svalna av istället.
48, 49, counting down to 48 kilometers in altitude. Expecting that transonic to come, so transitioning between the speed of sound and subsonics lower than the speed of sound in just a little under 4 minutes from now. And right now we've got kind of a lot of forward momentum, a lot of forward velocity, and then eventually by the time we hit subsonic. All right, here we go. So this is what we've been talking about, where we are going to essentially try to fully deploy those aft flaps and really stress them out. So again, this is meant to test the extremes for the vehicle.
Coolt. Att de ändå har den där kontrollen nu är helt galet.
See those flaps swinging out? Again, we're putting ship through the ringer on this flight in.
Det är det de menar att de stresstestar den. Varför det har sprängts hål längst bak på dem, det kanske inte är mig själva.
It's like we're still maintaining control.
Det har fortfarande inte varit lite hett precis ovanför heatshielden där på våran. Skulle behöva gå upp något. Kanske inte behöver göra, men kanske tycker att det är fair. Men två linjer till med.
All right, flaps earning their paycheck today, getting through kind of that max stress and.
Inte skada. Det är tungt, men.
Definitely things looking good so far. We're about 2 minutes out now from Starship becoming transonic.
One cool thing to note as we get some of those views showing kind of the whole length of the ship, one of the changes we made after Flight 6 was to change the tile line a little bit. So we had kind of scaled back the number of tiles significantly, as when we go to catch these ships, you don't want to, I think as Elon said, you don't want to shuck the ship as you catch it and knock all those tiles off. So we knew we were going to have to kind of peel back that layer a little bit. And the first time we did it was on Flight 6, and we saw kind of wrinkling and dimples almost in the ship as we were creating these hot spots in the uneven parts of the heat shield. And so we kind of address that. We smoothed it out. That's why you've got kind of that nice smoothed out black line now on the ship. And just looking at it, we can see kind of a little bit of hot spot, a little bit of warping almost. Near the payload door, you can see a little bit of colored patina up above it, but we don't see those kind of deep, almost, you know, they almost look like gouges on that. So it looks like that's been pretty successful. So, all right, we are less than a minute away from hitting transonic. Again, pretty soon our kind of our forward velocity is going to look like it's kind of falling off a cliff, and Starship will look like it's falling off a cliff as we essentially go into our belly flop. If you watched some of the high altitude tests or suborbital campaigns, we were able to test that. It was a pretty fundamental, like, can this thing actually fly? And we were able to prove that out with that suborbital campaign. And that's what we're about to see shortly here.
De sa att de skulle landa på tornet efter nästa gång de lyckades landa. Det tror jag inte de gör, men jag tror de kör det här skeppet, nästa skepp, och sen så kör de nog första skeppet, första version 3 av skeppet, för att säkerställa att allt funkar bra då med Raptor 3. Sen tror jag att de landar, fångar det. Det ser ut som catch pins, alltså fång.
All right, so at this point we've dropped below the speed of sound, so Starship itself is subsonic.
Ser bra ut. Ligger på bra.
We are starting to chill the engines for a landing burn attempt.
Se om det exploderar när de tänder motorerna.
Landing flip supposed to start in a little over 2 minutes.
Gått sönder där bak.
Subsonic Indian Ocean, we're on our way.
Starship is subsonic.
Kör vi belly flop.
There we go. Farewell space.
Belly cruising, kanske.
All right, so coming up in just a little under 2 minutes, so we're going to do the flip and the burn. So we're only using those 3 center Raptor engines, the sea levels, the ones that can kind of gimbal, that can move around and steer.
Nice.
Dipping the nose down a little bit.
Komma till rätt ställe.
Got 2 of our engines chilled in, waiting on 1 more. So again, we'll attempt to use 3 burns for that initial flip. We eventually go down to just 2 Raptors for the end of the landing burn.
Just about 1 minute now from that landing flip and landing burn start.
Så sagt, här är vi på känd mark då. Det har de gjort många gånger. Inte med version 2, 2-skeppet, men med version 1. Vi ser lite molnigt, kanske.
Structurally, we're looking good. Got good pressures in our nose cone for everything. Just about 30 seconds. So again, we're going to look for the flip. So Starship's doing its belly flop right now. We're going to do the flip. Swing out. Let's punch through some clouds first.
Jag vet inte vad jag ser för något. Är det sjön i alla fall? Den är rätt toastig han bak här.
Here we go.
Starship landing burn start up.
Vi ser tänds det 3 motorer. Vad händer?
Seeing 3 engines.
Yeah.
There's our flip. There's a buoy. There's a splashdown. Hey. Oh man. Yeah, farewell, Ship 37. Thank you, buoy cam. Landing flip, landing burn, splash out of the Indian Ocean. There we go. Whew. All right. That was pretty awesome.
Incredible flight
cool, right?
today for both Ship and booster.
Yeah, really incredible. So obviously we're excited here. It looks like everybody's excited over there. Tyler, how's it going over in Hawthorne?
We are super excited here in Hawthorne. It was another exciting Starship flight test in the books, and we hope you enjoyed those Starlink views. So congratulations to the team at Starbase and everyone here and around the company. So many employees have contributed enormously to the Starship program as we continue to iterate and make progress towards a multi-planetary future. So that's going to wrap it up for us here in Hawthorne. Thank you to everyone for tuning in today. It was great being with you today. Back to you guys.
That was absolutely incredible. Huge congrats to all the teams here. Again, we lifted off from Starbase, Texas, right at the top of our window at 6:30 p.m. Central Time. We saw Booster successfully lift us up through ascent, had a successful hot staging where Ship continued on with its suborbital trajectory. Booster came back down, had that boost back burn, and a successful landing burn with that unique engine configuration as well.
Yeah, and then Ship continued on its way, made it all the way into space. We got to see first ever payload deploy.
So exciting.
That was awesome. We got the door open, 8 Starlink simulators deployed, relit that Raptor engine, and then on entry we probably gave it a little bit of extra time in the oven, but made it all the way through re-entry. All 3 engines started up, landing flip, splash down in the Indian Ocean. Promised maximum excitement. Starship delivered.
Most
so
definitely.
Congratulations, all of our teammates here at SpaceX. It's been a year. Everybody that's worked on this program, this is what we're working for. So big congrats to all of them. Thank you to all of our future customers, too, for your support.
And we'd also like to thank the fine people of Cameron County, including the residents of its newest city, Starbase, as well as the Coast Guard, the Federal Aviation Administration, the Government of Mexico, and the Australian Space Agency.
Be sure to stay tuned to SpaceX on X for updates, more of the views. This is just a tiny amount of the views. We have so many views that we didn't get to feature on the broadcast. So we're going to be going through that over the next couple of days, and we'll be posting it all there.
Yeah, if you're interested in more launch coverage, head on over to spacex.com/launches for the most up-to-date information. In fact, we actually recently rolled out a new departure board featuring our upcoming launches with details like mission name, launch and landing site, and liftoff time. So be sure to check it out.
All right. We just launched the world's biggest rocket. Again, dropped a couple satellites off, suborbital.
Incredible payload deploy for today.
Nailed that double header into the ocean, splashdown, time to go through the data. Really crazy cool to hit all those objectives today.
Yeah, huge shout out to all the teams who make this look easy. And thanks to all of you for tuning in, and we will see you back here for Flight 11. Good night.
Skulle vilja ha... Finns det så vi kan se lite. Ja, det gör det. Bra. Då ska vi se. Vart hade vi det där? Tänkte vi bara skulle. Där är det helt och fint. Se. Här har vi någonting som har hänt. Men jag vet inte när det där hände. Vi hade ju lite bråte som flög iväg. När hände det där? På ena sidan, det här ser bra ut där. Det är 7 minuter in.
Ignites its engines.
All right, we're a little over 1 minute.
Vehicle pitching downrange. Booster chamber pressure nominal.
Se lite om vi ser när det här händer. Och en motor här nere som
We're a little over 40 seconds into flight. 33 out of 33 rapid
avionics,
engines.
power and telemetry nominal.
Getting good call outs, healthy systems on the booster as it starts to pitch over the Gulf.
Nej. Kan inte se. Se att
All right, we're a
fladdrar
little over
där.
1 minute into flight, about to pass through max Q.
Max Q.
Flög av någonting där.
All right, so we are through the period of maximum dynamic pressure, max
Nej,
stress
försvinner den
on the
motorn då.
vehicle as it continues to fly.
Our next major
Även
event
snart.
is going to be hot staging, which is happening in just over 90 seconds from now. To get ready, the booster will shut down all but 3.
Ta bort det. Där gick den. Se. Inget som tyder på någonting speciellt. Se om vi kan se något mer. Har inte. Kolla tidsstämplarna här också. Hot stage. 02:36 Miko. Jag ser ingenting här heller. Det måste vara på den sidan som är andra flappen där. 02 ska vara Miko nu. Där ja. Så hot staging där. Såg inget.
Separation confirmed. We've got 6 engines running.
Vad blev det ute på plötsligt?
Booster is
Ska vi se. Ja. Där ser det bra ut just nu. Får inte se den sidan. Ser också bra ut. Så vi har ju någonting här som håller på, som händer. Men jag vet inte, vi har klödka där som vanligt. Jag vet inte om det är någonting att överanalysera. Men vi har någonting som... Ja. Frågan är om det är någon vänt. Om det är någon vänt där. Det ser ut som att det är någon vänt här. Där med. Är det någon väntning som gör det där? Den går sönder på något vis. Här har det inte hänt än. Där hände det någonting. Är det varmt här? Ser det inte ut att vara varmt? Det är värmeutveckling här. Blått. Varför blir det varmt där? Borde inte bli varmt där nu. Det sprider sig varmare och varmare. Tycker jag i alla fall. Det ser ut som. Där händer det någonting. Det är från samma sida. Här kommer det. Vi ser om vi får se nästa vinkel. Det här kommer det. Alltså, det är om det här är is eller vad det kan vara för någonting. Det här ser inte ut att vara is. Kanske satsa pengar på att nästa gång vi ser den så kommer den vara skadad. Någonting hände. Jag visar då. Lite mer bröte. Vad är det jag funderar på? För det här ser inte ut som att det är... Ja, kanske att det är is också, men jag tror inte det är is. Men jag har alltid fel när jag tänker så här också. Så att... Men visar andra sidan då. När var det där? Där. 11:28. Så har vi 12. Så. Nej, det har inte hänt än. Där öppnar de dörren. Nej, kan det inte ha varit. Kan det inte vara satelliterna som har tagit i? Som har skadat den eller? Borde det inte ha gjort. Där är det skadat, ser du. Men, ser ni, varför är det skadat? Ja, det där är lite konstigt. Det sker alltså under tiden någonstans mellan att de håller på och fixar med. Där hade det i alla fall. Har det hänt redan? Där hände det.
Much higher frequency.
Men varför tror den på ljudet där? Ja, det är lite... 46 och... Här är 47. Nej, 46. Är det någon väntning som pågår eller? Ser ut som det. Eller något. 47 jämnt. Det var lite intressant. Jag har ingen aning om vad som händer. Det var ju väntning här från förut. Så jag vet inte. Nej, den är lite skum. Ja. Men där var det helt i alla fall och sen så kan jag bara se vart. Samma här som sker. Då är det också. Det är ju, alltså det känns. Du ser ju att orienteringen är också så att. Ja, intressant. Det känns som att det är någon form av väntning som händer där. Så det börjar inte där, men här börjar det någonting. Så puff. Ja. Intressant. Mer ska jag väl inte analysera den tänkte jag. Sett börja flyga saker, men allting gick bra. Hur såg landningen ut då? Se. Synd inte visa på grafiken att motorerna tändes, men man ser lite toasty ut ändå. Där. De är ju tända i alla fall, så att det är ju, alltså de gör ju sitt jobb. Jäklar vad röd den var. Men ska det se ut så? Hade varit intressant att se vad det var som hände där, men det kanske de svarar på sen. Ja, vi får väl se.